I may have made a mistake the last time I did this problem. It's problem number 4 from the straight line motion worksheet, and we are at the point where we need to find the acceleration function, and the acceleration function is the derivative of the velocity. And so I just rewrote the velocity function in terms of something that is a little bit easier to take the derivative of. So here is the velocity function that we're going to be using to take the derivative of and to find the acceleration. So the acceleration is the derivative of the velocity, meaning we're going to take the derivative of 1 with respect to t minus the derivative of this quotient with respect to t as well. So we have t squared plus 2t plus 1 down here in the denominator, and we have a 9 up there in the numerator. Okay, well, we know first of all that the derivative of 1 is 0. Okay, and then I think this is probably where I made my mistake. I didn't leave that minus sign out in front, but anyway, let's leave that minus sign out in front here, and then let's find the derivative of this quotient, and the derivative of the quotient is low d high minus high d low. And I'm going to need to back up just a little bit here. I think I'm going to need more room. So low, let's see, equals negative. Alright, the low would be the denominator, so t squared plus 2t plus 1, and that's multiplied by the derivative of the numerator, and the derivative of the numerator is 0, minus the numerator multiplied by the derivative of the denominator. And the derivative of the denominator is 2t plus 2. Okay? All over the denominator squared, t squared plus 2t plus 1 quantity squared. So let's see if we can simplify this a little bit here. We know that 0 times this trinomial here would be equal to 0, and we get negative 9. And so this is what I'm going to do here. I've got the negative out on the outside, and we're going to multiply that by the negative on the inside. That's going to give us a positive 9. And I'm going to have to transfer this to the other slide. Maybe we can just erase the top part so I can still see it. That way I can still see it. Okay, give myself some room here. Alright, so then this simplifies to a negative 9. I'm just going to leave it like that. I'm going to multiply this by 2t plus 2 all over the t. I'm going to factor this out again. T plus 1 squared. Maybe that wasn't so good. Maybe I'll just leave it like it is. I think that'd probably be easier to understand. T squared plus 2t plus 1 quantity squared. And then again, the negatives cancel each other out. And so the numerator is positive 9. And notice that I can also factor out a 2 from this binomial over here, and that gives me 18 over t plus 1 to the 4th, really. So I'll let you figure that out. It's t plus 1 to the 4th, and I just want to do that because then I can go ahead and cancel one of the t plus 1's in the denominator, and I get 18 over t plus 1 to the 3rd. So that's the easiest way to write that. I would just challenge you, if I didn't show you enough steps, write it out yourself, factor it, factor that trinomial again, and you'll see that unless I made another mistake, I'm pretty sure this is pretty accurate here. A sub t, or a of t. So we have the acceleration in terms of t. We have back here the velocity in terms of t, and that's the velocity in terms of t. And I don't remember where we were going with the acceleration. I just kind of jumped into this. I was sent a message saying they thought that I made a mistake on this. So let me check my video and see how it goes and see where I'm at. Well, I just watched part of the video, and we did need the acceleration. We needed to figure out whether the acceleration was negative or positive, and as it turns out, everything that I said from here on out was based on the acceleration being negative. But in fact, the acceleration is positive because t is always positive, or at least greater than or equal to 0. But as t is greater than or equal to 0, the acceleration then is always positive because it's 18 over a positive number. And then let's see how that affects the rest of this. Speeding up and slowing down, that's going to change this. My apologies. Let's see if I can fix this for you. Okay, I think I've got it now. I do apologize if this totally messed you up. And as I look back at this problem, I realize it doesn't make any sense to be slowing down from t equals 2 to t equals infinity, or and it doesn't make any sense that it's speeding up just before it stops. So with the new developments here, in which we know that the acceleration is, and I'm going to actually, let me do this in bright green. 18 is the numerator, not negative 18, but with the new developments of the acceleration being positive over the entire interval from t equals, well, all the time from as t is greater than or equal to 0, when so if the acceleration is always positive, it means it's always pushing right, and so when moving and pushing are going in the same direction, we are not slowing down, we are speeding up. Okay, so since acceleration and, let me start over here at from t equals 0 to t equals 2, the object is moving left, but the acceleration is pushing right, and so therefore we are slowing down. And this object is slowing down from t equals 0 to t equals 2. And then once it hits 2, so if you notice down here in the lower part of the screen, the object started at 10, moving left, gets over to 6 at t equals 2, the position is 6, and then at t equals 2, the object is stopped, and then after t equals 2, the object starts moving back to the right, and it moves right forever. Okay, so it moves left initially, slowing down, and then right after that, and speeding up forever. So moving right, pushing right, that would be speeding up, and that's when t is greater than 2. So again, my apologies for the mistakes on that one. It only takes one mistake to ruin the entire problem. Speeding up, slowing down, those intervals are as a result of me making the initial mistake on the acceleration always being negative. But given, so just to summarize, the object starts at 10, moves to the left from t equals 0 to t equals 2, slowing down the whole way, gets over here to position 6 at time t equals 2, stops, turns around, starts going back to the right, and speeding up the whole way from t equals 2 to infinity, and moving right and speeding up the whole way, and it just continues to move to the right. That's it. Alright, hope that helps, and I guess that's the last part of the slide, so I will hopefully if you've gone back over this, you'll be able to make sense of it and be able to answer any questions in the future. Thank you.